Hello, welcome. I'm sorry that I cannot be here today, but we will still review. The plan for today is we're going to review chapter 3. Okay, I'm going to do some proofs with you. We'll see how long those take. If there's extra time at the end, I'm going to ask you to open up to the chapter review on page 180. And you guys can work together on studying together. I do want you working on studying. I want you to practice these, solving for variables, being able to go through proofs and stuff. So that is what we're going to be doing today. So let's get started. Let's see here. Whoever is in seat, I can't remember what I've done in the past, honestly. Let's just say whoever's in seat 1A. 1A. If you're in seat 1A, you're going to come up and pause this whenever I ask you to, okay? So, here we go. First proof. Given, we have this picture. Given, angle 1 is congruent to angle 2. Angle 3 is congruent to angle 4, so these two are congruent to each other. These two are congruent to each other. We, in the end, have to prove that L and M are congruent. Now, we look at this and what do you notice? How could we maybe relate L and M together? Think through. How could we maybe relate L and M together? Okay, well, hopefully you're saying something along the lines of, what if they are both parallel to N? Oh, did we learn a theorem about that? Yeah, okay, so what if they're both parallel to N? So, I want you to try, just try, okay? It's just a few steps. Try to think through what you know from here and how I could relate all these together so that they're both parallel to N, thus making them parallel to each other, okay? Can we prove L parallel to N, and can we prove M parallel to N? Can we do that? Okay, so that's your job. Here's who I want working together. If we have 1, 2, 3, 4, we're going to put 1 with 4 and 2 with 3. 1 with 4 and 2 with 3, okay? Actually, let's switch that. Change my mind. Let's start out with 2 and 3. We'll do it this way. Okay, 2 and 3, you're starting, okay? Give the first statement and reason, then switch. First statement, or second statement and reason, then switch, okay? However many times you need to go back and forth, we're starting with 2 and 3, okay? So I'll move this down so you can write, copy this, and 1A, come on up and pause the video to be able to do it. Okay, so you should have paused the video, you should have tried it on your own. Here we go. Obviously, we're going to say angle 1 is congruent to angle 2, angle 3 is congruent to angle 4. That is given. Okay, do I have transitive property here with that information? No, I don't. Okay, so then I look at what else I can do. Well, looking at 1 and 2. Just looking at 1 and 2. What kind of angles are those? They're alternate interior angles, right? So if I know that alternate interior angles are congruent, what do I know about the lines that their transversal is going through? Well, if I know that they're congruent, I know that the lines are parallel. Okay, so I can say that line L is parallel to N. Do you agree with that? What theorem says that if the alternate interior angles are congruent, then their lines are parallel? What theorem is that? Alternate interior angle theorem? No, converse. Remember, the converse starts with them being congruent and ends with the lines. We're allowed to say the lines are parallel. So we started with the angles being congruent, and we can say now L and N are parallel. Now, is that what we wanted? No, we wanted M. So, what do we have to look at next? Well, let's look at N and M. Okay, I know 3 and 4 are congruent. What does that mean about N and M? They are parallel as well. For the same reason. So I'm just going to write it right there and not have to write it again. Done. Okay, so now what can I say? Now that I have L is parallel to N is parallel to M, what can I say next? I can actually end this proof. L is parallel to M. Why? Well, because they're parallel to the same line. Now, did this one have a name? No. But, you know, I mean, I can remember it right now, but maybe you don't remember it. That's okay. It doesn't have a name, so we just say, if two lines are parallel to the same line, they are parallel to each other. I'm just describing it. I'm just describing it. And there we go. Et voila! We have a proof. We have a proof. Okay, so there's our first proof. Let's try another one. If you need to come up and pause it, do so that you can write it down. Otherwise, let it keep playing, and I'll show you another proof. We'll go through another one. Okay, write a two-column proof for theorem 3.12. Given M is perpendicular to L and N is perpendicular to L, prove that M is parallel to N. Okay, I've given you some of the number of steps, not some of the number of steps, but the number of steps here. Okay, would you be able to work through this piece by piece? Just start with something at the beginning and see if you can go through and get to it piece by piece. Okay, this isn't too challenging of a proof. Are we allowed to use theorem 3.12 in the explanation? No, we're trying to prove that if they're perpendicular to the same line, that means those two lines are parallel. We're trying to prove that. Okay, so we have to go through and use previously known things here. Okay, so 1A, pause the video. Oh, wait, sorry, hold on. Let's give you the groups I want. Let's see here. We'll start with, whoops, 4 and 3. 4 and 3. Okay, so you're going to start 4 and 3. You're going to start here. Let's see here. I'll make it so that you can see what we're doing. You're going to start 1A, pause the video. Here we go. Go back and forth. Okay, so you have tried it. Let's see how you did. First thing, obviously, M is perpendicular to L. M is and N is perpendicular to L. Okay, given. Now I'm just going to start working through things here. I'm just going to name two angles. Let's use those two. It actually doesn't matter which ones we use, but let's just use those two. Okay? What do I know about these two angles? What do I know about these two angles? Okay, well, I know that angle 1 is what kind of angle? Angle 1 is a right angle. Why? Because they're perpendicular, right? Definition of perpendicular lines. Okay, what do I know about angle 2? Angle 2 is a right angle. Why? Because they're perpendicular. So what would my reason be? Definition of perpendicular lines. Okay, so now where can I go from there? Angle 1 is a right angle, angle 2 is a right angle. Where can we go from there? Well, what if we said angle 1 is congruent to angle 2? Why are we allowed to say that? Well, I'm glad you asked, because all right angles are congruent. Okay, we've used this before. We know that all right angles are congruent to each other because they're all 90 degrees. So all right angles are congruent. Okay, so now what is my final step? I can finally say that M is parallel to N. Now somebody, let's see here. Never mind. What is the reason that I'm allowed to say they're parallel? Well, the reason is because those are corresponding angles. I chose corresponding angles. I could have chosen other ones and used another theorem, but I chose corresponding angles. So the corresponding angles, converse or theorem? Converse, because we started with the lines, or the angles being congruent, and we're ending with the lines being parallel. Okay, so remember, the theorem starts with lines parallel, goes to angles congruent, or remember, supplementary. Okay, the converse goes from angles, whatever, congruent or supplementary, if you're dealing with the consecutive interior, and we can end with lines that are parallel. And remember, last but not least, corresponding is the only one, I'll move this up, is the only one that is a postulate. Let's write it out, postulate. Everything else is a theorem, okay? So those are all the random little facts. Random little facts. If you need to write this down, 1A, you can come up and pause it really quickly, otherwise let it play. Okay, last one we're going to do together. I didn't write this one out, so let's see if we can fit it on there. Okay, notice all of these are blank right here, okay? So, here is we're doing number 7. Let's see if I can adjust that a little bit. Okay, so we're trying to prove theorem 3.1. Okay, so that, what is theorem 3.1? That if angle 1 is congruent to angle 2 and they're a linear pair. Oh, okay, so we're just trying to prove that if these two are a linear pair and congruent, that means the lines are technically perpendicular. That's what we're trying to prove, okay? Now, here are all the steps. They have not given you any of the reasons. I want you to see if you can figure out the reasons, okay? So look at it, see, did it come from given? Did it come from the one before? Where did it come from, okay? So we're going to start out with, I'll move this after a second, but we're going to start out with, let's see, how about, has 1 started out yet? No, let's do 1 and 4, you're starting. 1 and 4, you'll start. Your job is to give, put you down here. Your job is to give the reasons, okay? So go every other, there are 10 of them, okay? So each of you get to answer once. 1 and 4, you're together, you're explaining 2, then back and forth and back and forth. 4 with 3, back and forth, back and forth. And then I'll go over it. This is the last one that I have, okay? So 1A, come pause the video and do this. Okay, so you should have tried it. Here we go. Angle 1 is congruent to angle 2. Well, they told us that, given. 2, measure of angle 1 equals measure of angle 2. Okay, that just comes from the first one. Definition of congruent, angle congruence, whatever. Either way is fine. Number 3, angle 1 and angle 2 are a linear pair. Did we get that from here? No, neither of us tells us that they're a linear pair, but wait. If we come over here, angle 1 and angle 2 are a linear pair. Well, there you go. Given. Okay, number 4, angle 1 and angle 2 are supplementary. What tells us that if they're a linear pair, then they are supplementary? What tells us that if they are a linear pair, then they are supplementary? Well, it is called the linear pair postulate. Did anyone get that? Linear pair postulate. Did anyone get that? Linear pair postulate. If something is a linear pair, that means they are supplementary. That is my linear pair postulate. Okay, why am I allowed to say that the measure of angle 1 plus the measure of angle 2 equals 180? Well, that's just our definition of supplementary angles, right? So, definition of supplementary angles. Okay, why am I allowed to say that the measure of angle 1 plus the measure of angle 1 equals 180? Well, what changed? Excuse me. The 2 became a 1. So it's going to be substitution, right? Substitution, property of what? Well, we're dealing with equality, so we've taken it from up here, measure of angle 1 equals measure of angle 2. We replaced it, so of equality. Okay, now this one, if you didn't get this one, I kind of understand. It's the distributive property of equality. Distributive property of equality. It's the, like, backwards of it, okay? That's what it's called. If you just put simplifying, I would have accepted that too, or something along those lines. Okay, now, number 8. How did I get from here to down here? Well, I divided both sides by 2, so what's that? The division property of equality. Number 9. Why am I allowed to say that angle 1 is a right angle then? Well, it says it's equal to 90 degrees, so that's just a definition of right angles. Notice these are all equal signs and we're using a lot of definitions. Okay, number 10. Why am I allowed to say they're perpendicular? Definition of perpendicular angles. Done. Now that wasn't too hard, was it? And there we go. Okay, so we've gone through 3 proofs together. This is exactly what I would have done in class, so there's nothing more that I would have done. Just some reminders maybe. Just some reminders. Let's see here. Some blank page. What happens if I have like that and I have x plus 3 and 2x plus 4? What would x have to be in order for these 2 lines to be parallel? Well, first off, the question we have to ask is, what type of angles are they? So what type of angles are they? Say it out loud. Hopefully you said consecutive interior angles. Consecutive interior angles are the only weird one. What do we know about consecutive interior angles? Well, we know that for consecutive interior angles... Okay, so since these 2 angles are supplementary, we're going to take them and we're going to add them together and we're going to set them equal to 180. So on your quiz that I handed back Friday, this is maybe what I wrote, something that looks like this. This means add them together and set them equal to 180. So x plus 3 plus 2x plus 4 is equal to 180 degrees. From here, you know what to do. Combine like terms. X plus 2x is 3x. 3 plus 4 is 7 is equal to 180 minus 7 from both sides. 3x equals 173. Well, that's not divisible by 3. That's okay. X equals 173 over 3. Sure, we can say that. Or we could say, what, 6? No, 5. 23, 7 and 2/3. 57 and 2/3. There we go. There's x. Okay? So solving for the different variables. What if they weren't consecutive interior? What if they were alternate interior? 4x and 10x minus 3. I guess I like 3 today. Okay, what kind of angles are these? Alternate interior. So now this is what I would have written on your quiz. I would have put an equal sign if you didn't get this one right. Because alternate interior angles equal each other. So we're going to take 4x equals 10x minus 3. Now remember, this is only if they're parallel, the lines are parallel, or if we're trying to say that they're going to be parallel. Okay, remember, we're allowed to have other types of lines. Like technically, those 2 will be alternate interior. But since the lines aren't parallel and we're not trying to prove that they're parallel, we're not saying that they're equal. Okay. So anyways, so then we solve. I would subtract 10x from both sides. Oh, look, this one works out perfectly. Negative 6x equals negative 3. X equals 3 over 6 is 1/2. There we go. Solved. Done. Okay, so practice more of those. Make sure that you're good at that. You're going to need to know about skew and perpendicular and parallel lines, the different types of angles, definitely the slopes. Like a vertical line is what kind of slope? Undefined, falling off a cliff. Horizontal line is what kind of slope? 0, right? 0 fun going cross-country skiing. Different kinds of slopes with parallel and perpendicular lines. The different theorems, you do need to know the theorems. You need to be able to name them. If I ask you, the hypothesis is this, the conclusion is this, what theorem is it? Be able to answer it. Finding slope based off of a picture, finding slope based off of 2 points. Figuring out if two equations are parallel or perpendicular, so I might give you like 3x plus 10y equals 6, and 4x minus 6y equals 7, whatever, that's not anything. But you'd have to solve for y, subtract 3x on both sides, divide both sides by 10, work through that, figure out if they're parallel, perpendicular, or maybe neither. And then the last thing that we were working on Friday would be like if it's, write the equation of a line that goes through the point 5, -1, and is perpendicular to y equals 5x plus 10, whatever. Okay, so you look at this, and what's the first thing you have to think? You're trying to write an equation of a line through here, perpendicular to this line. So what do you do first? Well, first you got to figure out your slope. Your new slope is going to be what? Perpendicular? So, -1/5. Then we're done with that line. Okay, we have a point, 5, -1. Okay, so we plug it in. What's slope-intercept form? Y equals mx plus b. So y is -1 equals m, -1/5 times x, 5 plus b. That became -1. I would add 1 to both sides. That's interesting. So b in the end would be equal to 0. I'm running out of paper, so I'm going to write it over here. Y equals plus 0, so we don't even care. -1/5x plus 0. So we're not going to write it because y is y, m is -1/5, x is x. Remember, in the final equation, you have to have an x and a y. But we don't write plus 0 because plus 0 just doesn't do anything. Okay, so you're going to have that kind of stuff. So what I want you to do, as I said earlier at the beginning of class, is we just went over proofs. It took me 20 minutes to do that, so I'm not sure how much more time you have left based off of how long you actually worked through the proofs, but with whatever time you have left, I do want you to open up to page 180 and start working through this chapter review, okay? You can work together, but I want you to figure out the different things. As for, I'm looking at it right now, as for flow proofs, I'm not going to have a specific flow proof on it, but you still need to be able to think through what the reasons are, because flow proofs and two-column proofs are exactly the same, they're just written in different ways. So I would still use those examples to figure out what your statements and reasons are. But other than that, study hard tonight. I put the answer key up on Saturday, so the answer key to all the practice pages on RenWeb, or not RenWeb, on Schoology are up, and I will see you tomorrow ready for a test. Have a great day. Please study hard. Goodbye.